This week's program focuses on human demography, polling techniques, and the concept of race. Don't go away. On July 11th, 1987, mankind celebrated a birthday unlike any other. On that day, according to United Nations statistics, the world's population capped the 5 billion mark. The population is growing at an alarming rate. Where will it ever stop? At the turn of the last century, the population of the world stood at 800 million. By 1987, that figure had jumped to 5 billion. 100 years from now, it will have climbed to 11 billion. What then? Demographers predict the world population will have stabilized by then. Between now and then, though, they are concerned about the effects of a demographic explosion, likely to occur only in the poorest parts of the world. We are already witnessing a disturbing division of the planet into two distinct worlds. On one side are the poor countries. Poor countries are having great difficulty sustaining their people, over half of whom are under the age of 20. The other half of the world is represented by rich countries, whose population is aging and barely able to ensure its own renewal. To try and predict demographic trends worldwide, demographers combine birth, death, and migration indexes. These indicators enable them to study the movements of populations on an annual basis. Populations shift constantly as they gain and lose individuals. Births and immigration represent gains, whereas deaths and emigration constitute losses. It's the relationship between these two factors that allows the specialists to measure the growth rate of a population. The birth and death rates of rich nations are about the same, which explains their virtually nil growth rate. Conversely, the growth rate in poor countries is high because there are more births than deaths. Another determining factor is the fertility rate, that is, the number of children per woman. This parameter indicates the capacity of a population to renew itself. In Western nations, the fertility rate is in the area of 2. That is the level required for a population to maintain the same number of individuals from one generation to the next. In most third world countries, the fertility rate is very high. In Africa, Asia, or the Middle East, for instance, the fertility indexes are close to 5 and sometimes as high as 8 children per woman. Another important indicator of demographic change is a population's distribution by age. This composition is illustrated by the age pyramid, a diagrammatic pattern of the relative proportion of each age group within the population at a given time. The broader the base of the pyramid, the greater the number of young people or future parents. This is the type of pyramid that characterizes most developing countries, Mexico, for instance. In affluent countries, on the other hand, the age pyramid bases are very narrow, indicating few children. Age pyramids are fairly reliable forecast indexes. Indeed, few children means few parents in the next generation. Putting their various observations together, demographers have come up with several scenarios. The most pessimistic predicts that the next baby boom will occur in the poor countries. However, it will be limited in the medium term by food shortages, which will give rise to a higher death rate. Limited growth rates due to food shortages can be observed in a number of species. For example, bacterial cultures placed in a nutrient environment double their population for every unit of time. Their growth is said to be exponential. However, their rapid growth rate reaches a plateau when there are no longer sufficient nutrients to sustain their development. Most demographers do not believe this growth pattern applies to the human species. In their view, global population will stabilize at some point, not for lack of food, but because we will have entered into an era of demographic transition. According to this theory, a modernizing society changes demographic pattern. Characterizing the old pattern was a balance between high fertility and mortality rates. This was the case in most parts of the world, including Europe and North America, a little over a century ago. Today, however, the demographic pattern of rich countries is defined by low fertility and low mortality rates. This change can be explained by improvements in living standards and medical care, and by changes in mentality. It is believed that in time, a similar pattern will also take hold in the poor countries. It is only during the transition phase that there is an imbalance. Since mortality decreases faster than fertility, substantial increases in population will occur. Most researchers predict that the world's population will double one last time in the coming decades, then level off. The greater part of that increase will occur in the third world. They believe there will be sufficient resources to feed everyone, but no one is yet able to say whether or not these resources will be distributed more equitably around the world. Back in antiquity, most political, military, and religious leaders consulted the oracle before making an important decision. Today, our leaders no longer rely on soothsayers. They have replaced them with polls. Unlike a census, where a questionnaire is distributed to every member of a population, sampling surveys, or polls, are only conducted on a small portion of the population. A sampling survey, as its name suggests, is based on sample groups of individuals whose distribution by age, sex, or occupation matches that of the reference population. Theoretically, the only valid means of establishing a representative sample is to select individuals at random. This type of sample, called random or probability sampling, ensures that every member of a population has the same chances of being represented within the sample. Random sampling requires comprehensive lists of the population, or sample frames. Survey organizations often use the alphabetical listings of telephone directories. Based on these lists, they will make systematic drawings. For example, pick a first person at random, then pick the entry listed 1,000 names further down the list, and so on. The individuals selected are then asked to answer a questionnaire over the telephone. Another method consists of household sample surveys. Here again, survey zones are picked at random. Within each zone, the pollster begins from a place which is also chosen at random. From there, he will visit one apartment building out of 5, for example, and in each building, one door out of 3. The results of random surveys are highly reliable, and their accuracy can be measured, but they are not always feasible because they require a sample frame, namely a complete list of the population. For that reason, quota sampling is often preferred. Quota samples are samples representing a small-scale model of the population under study. When creating a quota sample, the experts are careful to make sure it closely reflects the population. For example, men will make up 48% of the sample and women 52%, as is the case in the overall human population. Even more faithful and accurate samples can be drawn up by combining such variables as age, sex, and occupation. Quota sampling is easier to manage and less expensive than other survey techniques, since the pollster knows from the start the types of people he will be interviewing. In quota sampling, the quality of the survey depends largely on the interviewer. If he fails to apply his quotas rigorously, the accuracy of the survey will suffer. Moreover, quota sampling requires detailed information on the population. In most cases, this information is provided anonymously by census organizations. However, the information is often outdated. And some countries have very little statistical data available. But an inventive technique compensates for the lack of a complete and up-to-date sample frame. It consists of establishing databases by analyzing satellite images. This technique provides up-to-date, accurate, and readily usable information of a city's population. A color code distinguishes inhabited zones from green zones, for example. The first step consists of selecting residential blocks by systematic drawing. This is done by first placing a sheet of paper over the satellite image and selecting the blocks at the intersection of the meshes. Then, in each block, the households to be polled are picked at random. Whatever the sampling technique, the results of a survey or opinion poll undergo a complex analysis process. The survey specialists analyze the results statistically. Their analysis will determine the survey's margin of error, which depends, among other things, on the scope of the sample and on the selection procedure, called sample design. For example, for a same survey, the margin of error for a sample of 1,000 people will be much less than for a sample of 100 individuals. Margins of error also depend on the gap between results. For instance, when 80% of respondents say they plan to vote for a candidate, there is every likelihood that candidate will be a shoo-in. However, when two candidates are only a few percentage points apart, the margin of error makes it impossible to tell which of the two will win. Nowadays, countless surveys and polls provide the experts with a wealth of information on various aspects of our lives: economic, political, cultural. But are we, ourselves, swayed by opinion polls? An opinion poll on the subject might be worthwhile. An essential premise underlies the scientific value of any poll. The respondents and their opinions are all of equal importance. However, people have not always been considered equals, as attested by the age-old concept of human race. Defining a race comes down to determining a group of people who share the same traits. But how are such traits chosen? The oldest approach, today refuted by the findings of genetics, consisted of classifying the human species according to its visible physical characteristics. In the 18th century, for instance, explorers' reports, often inaccurate and exaggerated, had scientists drawing parallels between the physical traits of black peoples and apes. Blacks were described as having a snout, a head pushed in at the temples, and teeth that protruded on a slant. Such a view inferred that humans all descended from different ancestors. And yet human beings can obviously reproduce among each other, regardless of race, and beget a fertile progeny. That is the biological definition of the species. It was therefore accepted that all men belong to one and the same species, Homo sapiens. However, the fact that men belong to a same species did not put an end to the concept of race, which dictates that the value of an individual of a people depends solely on physical appearance. To better define this vague concept, 19th century European scientists founded craniology. The purpose of this science was to draw a relationship between the size of the human skull and intelligence. It was established that the size of a normal skull should be no smaller than 1,400 cubic centimeters. Oddly enough, the only race that satisfied that condition was the white race. It was later discovered that the brains of a number of Nobel Prize winners did not measure up to that standard. Proof positive that the theory of craniology was unfounded. The concept of race therefore remained very fuzzy, depending on the traits studied, such as skin color, height, for example. The number of races ranged from 1 to 63. With the advent of the 20th century and genetics, the scientists tried to give a more objective definition to the concept of race. They no longer classified people according to their habitus, that is, their physical traits. Rather, they grouped them by genotype, that is, according to the genes they share. The hypothesis was then advanced that one or several genes could be present in large proportions in some peoples and totally absent in others. These marker genes would be the characteristic labels of a race. The discovery of the ABO blood system in 1900 opened the way for the first time to the world of genotypes, the hidden genetic characteristics of people. The ABO system made it possible to compare the genes of human populations. Indeed, the different blood groups correspond to specific genetic combinations. The researchers calculated the relative proportion of these genetic combinations in populations. They were able to demonstrate that the frequencies of these genes vary from one human group to the next. For example, among European populations, the frequency of the gene of the B blood group decreases from east to west. However, the genetic differences observed in no way corresponded to the groups defined as races. More surprising still, the research shows that there is more variation within geographic populations than there is between them. Two people from the same population can look alike physically, but be quite different genetically. And two people of different skin colors can be closely related genetically. These studies prove that there is no definite boundary between peoples, but rather a bond of continuity. Anthropologists believe that the genetic similarity between peoples can be explained by a common origin, probably in Africa, and by the repeated migrations of human populations. The physical differences between peoples would be due to our ancestors' capacity to adapt to their respective climates. In warm countries, a black skin provides better protection against the sun's ultraviolet rays because it is high in melanin, a black pigment that absorbs these rays. On the other hand, in countries where the sun is less intense, a skin low in melanin is beneficial since it absorbs the ultraviolet rays needed to produce vitamin D. For modern geneticists, the concept of race, therefore, has no biological basis. It is an illusion stemming from social prejudice. As things stand today, there is no scientific evidence that permits us to draw boundaries between men. With their obsession to define races, our ancestors overlooked one crucial factor. On Earth, any man can sire a baby with any woman. It's even a major problem. Since the beginning of this program, at least 5,000 babies were born.